Good afternoon and welcome to the ESAB Specialty Alloys live event. My name is Clemente Talarico, and with me as the presenters today we have two of them. We have Mr. Peter Stones and Mr. Tiago Pereira, as well Mr. Per-Åke Bjornstedt for technical support. I'm pleased to announce here the sixth presentation of ESAB Specialty Alloys, which will happen every third Friday of the month at 14:30 European time via Teams live event. The sixth presentation of the program will be the one starting in few seconds with the title, Why should you keep to the recommended welding parameters, quality control and record keeping? We will be very happy to answer your questions at the end of the presentation, which you can type in the Q&A box you will find on the top right of your screen. We intend to present on about 30 minutes and take 10 to 15 minutes more for answering your questions. And now let us start with the show with Peter and Tiago presenting. Enjoy.
Thank you, Clemente. Good afternoon, everyone. It's my pleasure to be presenting at this live event again. As Clemente said, we intend to talk for about 30 minutes. So really, we're just giving bullet points. We're giving pointers so that people can ask the right questions. Please feel free to contact us if you need any further information or you would like us to go in more detail with any of the things that we've covered. Everyone's contact details will be available at the end of the presentation. And all the slides are available on request. Again, if you drop us an email, give us a call, then we're quite happy to send a copy of the slides. So, why is it necessary to follow welding recommendations? Why do welding engineers go to the trouble of doing this? It sounds like fairly obvious that you want it to work, but is it? To make the welding easier? Are they trying to make it as easy as they can for the welders? Are they trying to reduce the amount of expensive filler metals, perhaps, particularly stainless nickel alloys? Then overuse of the filler metal, using more than you need, can cost a lot of money. Or are they just trying to maximize productivity? So why is it necessary to stick to these recommendations? From the other side, what are the consequences of not sticking to the rules? We can all make things quicker. I can reduce the welding time. So if I just go over the interpass temperature a little bit, I can get another welding before I go home. I can get another pass in. I can increase my travel speed, or get it down as quickly as possible, for example, or I can get to the interpass temperature quicker by quenching with water, for example. And post-weld treatment, it requires pickling and passivating, but hey, that takes an awful long time. It's a little bit fiddly, so I can just give it a quick rub down with a wire brush and the weld will look fine, for example. So what's the point of a WPS, a welding process specification? Well, the welding engineer has gone to an awful lot of time, an awful lot of trouble to detail every single joint in the fabrication, and the whole purpose of it is to ensure that if it's welded to the parameters that he's laid down, that it achieves the required level of, firstly, mechanical properties, and alongside that are the corrosion resistance properties as well. The way that stainless steels, nickels are welded and post-weld treated affects greatly the amount of corrosion resistance that they have, and doing it wrong, you just won't get those levels that's required. Uses the data sheets on the base and the filler material, so all the manufacturers of filler metals and any kind of sheet, plate, bars, they all produce data sheets given their recommendations. It's got the properties that the base material is supposed to have, their recommendations for welding, and alongside that, historical data. Generally, this has been welded before. Usually this has been welded before, the design is not new, for example, so you can use historical data. But ultimately, and depending upon the position and the requirements of the weld, empirical testing. You have to prepare welds. and test them to disruption to make sure that they're fit for purpose. So anybody that can weld can tell a good weld straight away, or rather you can tell a bad weld from just by visual inspection. You can see if there's excessive amounts of spatter, if the bead shape itself looks terrible. You can see porosity if it's in the surface, and then cracks as well, obvious signs of a poor weld. Even the basic NDT methods will highlight any micro cracks or lack of fusion in the sidewall, or indeed inclusions or porosity within the weld itself. So you can do that with NDT. Yeah, that's fine. However, some of these problems occur that are not visible and are not possible to detect with NDT. So what happens with if you ignore the parameters for interpass and heat input, or you cool things down too quickly? So this is an example of a stainless steel pipe that, on the face of it, the weld looks pretty good. There may be a bit of heat tint, but you don't really know that from a photograph. However, in service, this construction lasted about a month. It's stainless steel. It should have lasted years. And when the weld was microsectioned and looked under a microscope, it was very, very obvious that too much heat had been put into this TIG weld. So much so that we had what's called sensitization. So basically, you get a precipitation of carbides at grain boundaries. So essentially, you're robbing the stainless properties of the steel. It's got sensitized, so it's not stainless steel. Essentially, in a nutshell, it's not stainless steel, so it rotted. And on the face of it, it looks a good weld. You'd be pleased. Well, I'd be pleased with it. So, particularly with something like Duplex stainless steels, Duplex, as you know, is a mixture of austenites and ferrites. That's a good Duplex structure. You've got a nice mix, and that's what you were trying to achieve when you're cooling down, when you're welding, and it cools down. You're trying to get in the middle of the road just the right amount of heat to enable the structure to reform as it's supposed to. If you ignore the interpass and you think, I'll cool it down with water, quench it with water very quickly, then what happens is massive grains structure is promoted, and it's very brittle. So this thing does not have the same properties as this. It's not a proper formed Duplex structure anymore. If you put too much heat in there, you're going to put an extra pass. You've gone over the interpass temperature, or generally you wound things up to put maybe a bigger rundown. Then you get these things into metallics, sigma phase, this dreaded sigma phase that we talk about with Duplex stainless steels. So these are carbides that are coming out in the microstructure, and essentially these are points of weakness. So the black dots are areas that are not Duplex stainless steel. These are points of weakness, and if there's enough of them, then you're taking away all of the both the mechanical and the corrosion resistant properties of the steel. Okay, so it's very important to follow the recommendations. That's why they're there, in order to be able to achieve this kind of structure for a Duplex stainless steel. Just a quick note on post-weld cleaning. Pitting corrosion. Pitting corrosion is particularly important and relevant to oil and gas fabrications, for example. The materials selected are generally required to be resistant to pitting corrosion. So it's a particular type of corrosion that you're trying to avoid. If this is a diagram really of the effect of the various post-weld cleaning. So from a wire brush, you've got this much, and it doesn't really matter what the scale is, you've got this much resistance to pitting. If you grind it and get a bit better surface on it, then you can see the resistance is 3 times, 4 times better than with a wire brush. 4, 3, and 2 are mechanical polishing with progressively finer grain abrasives. So the finer that you get, the more highly polished it gets, the more resistance to pitting that it gets. And then ultimately, the best that you can achieve is by, number one, pickling and passivating. Then on this scale, you can see it's a good 10, 15 times more effective at increasing the pitting corrosion resistance. That's what I've got to say on WPSs and the importance of that. Now I'll hand over to my colleague Tiago, that wants to talk about weld tracking. Tiago, off you go.
Yeah, thank you, Peter. You can hear me properly?
Yes, perfectly well, thank you.
All right, wonderful. So, hey everyone, hope the webinar is being interesting for you all. I am Tiago Pereira. I am the product manager of Weld Cloud Notes, which is a software to manage welding documentation, essentially. I will be talking to you about weld tracking and why we should do it, essentially. If you'd move to the next slide, please. What is essentially weld tracking? So it is the concept of record keeping of welds that are performed in a company for a project. And this information needs to be kept by companies for a multitude of years. This is depending on the criticality of the structure, but also on the contracted, let's say for warranty purposes or just for traceability purposes. And all the information related to the project needs to be stored somewhere so that we can later down the line consult it somehow. And weld tracking is essentially a big part of what full weld traceability is. And it's a very important thing nowadays. Next slide, please. So there are a number of industries that are required to do it, either by jurisdiction and law or by customer requirements. These are, let's say, the most prevalent ones. So piping prefabricators do need to do this kind of traceability. I mean, you'll see piping used, especially the stainless steel ones. You'll see them in nuclear power plants. You'll see them in petrochem. You'll see it in a lot of places. Same thing for pressure vessels. These are big recipients that are under pressure. Also ships and structures. So essentially, these are structures that are very important, and if they somehow fail, there will be a large social consequence. For example, if a reactor explodes or if the bridge falls, that is not a good thing. So that's why these are the most, let's say, scrutinized industries. So these are just some examples. If you'd move to the next slide, please. Just to give you everyone a little bit of history and why it's becoming more and more important. So in 2010, there was a pipeline blast in California that killed people and destroyed homes. So the power company, which is Pacific Gas and Electric, used the standards that violated safety regulations. And in essence, the main issue was that the company did not subject the pipelines to appropriate testing. They chose cheaper methods to save money, according to the prosecutors. But in the end, what came to be found is that the problem was there was very poor record keeping. There was inaccurate and incomplete information. This is an actual consequence of the fact that there was no traceability. And part of this is because back then, this pipeline was built it was in the 50s. And as such, back then, there was also no such regulations, or the regulations were not as strict. And as such, it was hard to prove that in court. If you would move to the next slide, please. So as we move forward in time, there have been standards that have been developed in order to avoid those types of problems that you saw in the story that I just told you. So one of which is EN 1090-2, which actually has been approved in European jurisdictions to be mandatory by law. So fabricators have to keep full weld traceability in some execution classes of structures, and this means that they will need to keep record of each and every weld that they do. Of course, this also is related to the contract of these companies, but in general, this is on the part of the fabricator. So it's not just the end customer, it's not the energy company, it's not the bridge management company. The fabricator themselves need to keep this documentation as well. Also, ISO 3834, which is it is not mandatory by any jurisdiction, but it is more and more frequently being required by customer contracts, because this is a standard that defines what an actual welding quality system should be. And unlike ISO 9001, which is a quality standard, but is not enough to treat a special process like welding, ISO 3834 is capable of ensuring the quality of your welds. And because it is, in fact, a standard that helps improve weld quality, it is frequently requested by every type of pipelines or how do you call it, piping. Those kinds of jobs will request this kind of standard, that your company is certified by this standard. And then there is ISO 14731, which is a standard that defines the tasks and responsibilities for welding coordination. And it also defines what level of education the welding coordinator should have. For some roles, it will be required to have an international welding engineer. For some other roles, it will have to be an international welding technologist. And for some other roles, it will have to be it could be an international welding specialist. And these standards are pretty much to avoid these kinds of catastrophes, really. Next slide, please. So I'm going to give you a rundown of what needs to be tracked. So as you can see, there is a lot of information that needs to be tracked: welds, base metals, welders, all this information. This is kind of a summary, so I'm just gonna go deep down to each of them. So if you'd move to the next slide, please. Yeah, so base metals. This is kind of, let's say, the main kind of backbone of the industry. It's the material. For example, steel. Steel is the most used material all over the world for any structure. But the thing that you need to keep track of is this steel will have a certain chemical composition. It's part of a production run, and it will have a heat number. So this type of information needs to be tracked through a certificate, but in the material itself, say it's a pipe or a plate, it's frequently cut to match what you're going to build. But if you cut a portion that does not have the heat number, you need to write it down to make sure that when someone goes to the shop floor, they can understand that what material you're actually welding. And there's different levels of traceability for these certificates. There's the most common scenario is that there is a 3.1 certificates. And what does that mean? So let's say level 3 of traceability means that the chemical and mechanical tests of a specific heat number or a lot are they are done by an external agency. So an external agency will do all the tests. They will receive the test pieces, and they'll do this themselves to ensure that there is unbiased approach to it. There's also the 3.1, which is similar, but with an internal department of the company doing these tests. So the level of bias is a little higher, but this department needs to be separate from production. And level 2 and level essentially is done internally, and it's not to the specific lot that the company ordered. But all of this is specified in the certificate, and you need to keep track of it for the whole duration of the project and further on. And this information needs to be compared with the data that exists in WPS. What is the material to be used? It has to be this one that is written on the certificate. Next slide, please. So filler metals is pretty much the same thing. Actually, in here, you'll see an interesting thing. We have an inspection certificate with 3.1 on the chemical analysis and 2.2 on the mechanical properties. So the mechanical properties are usually not as much of a requirement for traceability, and as such, manufacturers are usually okay with asking for a 2.2 test certificate. But the chemical composition is very relevant. We want to make sure it's from the exact lot that was done. But in essence, this is very similar to the base material certificates. This information, the classifications of the filler metal, needs to be exactly the same that exists in the WPS. And all of this is also needs to be kept for a multitude of years. Next slide, please. And of course, that's it, the most important document in terms of how to weld. Which is this document, that welding procedure specification, that has all the variables that the welder needs to read and understand in order to weld. So there will be the parameters that he needs to set his machine, and he'll need to understand, is there going to be a preheat? Is there going to be an interpass temperature? He needs to understand the current voltage and all that. This is frequently generated by the fabricating company. The welding engineer in a fabricating company will write this down and put it in front of the welders. But in order for this type of structures, these documents need to be qualified, and they need to link to a qualified procedure qualification record. If you move to the next slide, please. So this is the document. A procedure qualification record is the document that qualifies the company to weld a certain range of variables. And this is based on a test that is done outside of production. It's a test that then, let's say a test piece, it could be a pipe or a plate, and this pipe gets cut into multiple pieces, and it goes for a couple of other tests. But in essence, this is the information. This document needs to be linked to the WPSs, and this is the type of document that is frequently created by an external agency that will oversee the procedure qualification. Although there are cases that this document could be generated internally. The only problem with that is that if you are working with nuclear, oil and gas kind of contracts, it's frequently not accepted to create welding procedure qualification records in-house. You'll need to use an external agency very frequently. But yeah, next slide, please. Also, naturally, the welders are the participants of the production, and you need to keep track of the people who were participating in the weld. And these people need to be qualified. A welder needs to be qualified to weld whatever is in front of him. You need also to register the date of production, and this is also beneficial to also from a productivity standpoint, because if you are tracking repairs for each welder, you can understand if the welder is in requirement of additional training, or maybe he is in a location that is, I don't know, windy, and he does not have the proper protection, and as such, you may be able to understand what his problems are if you are tracking the data. But in essence, tack welders, even though they are just doing a very small piece of the weld and it's essentially going to be melted over, they need to be qualified on the same standard as production welders. So these welder qualifications, they will also, similar to the PQR or procedure qualification record, they will provide a range of variables that the welder will be qualified for. In this scenario, this document is also frequently generated by an external agency who is overseeing the performance qualification, but it can also be an internal qualification. In terms of welder qualifications, it is usually less of a problem to use an external agency, but again, for high-profile contracts, the customers will request that welder qualifications are done by an external entity more likely than not. Next slide, please. Now into inspection. So these welds, unlike what specific gas and electric did, all of these welds, especially the ones that are in the more crucial kind of sections. So think about if you have two different sets of piping facilities, one of which is transporting nitrogen at -196 degrees Celsius, and another one that's transporting water at room temperature, you can imagine that the one at lower temperature may have more scrutiny. It's a more problematic weld, especially because at lower temperature, the steel in general performs differently than at room temperature. But in essence, all the tests need to be defined on a weld per weld basis. It could be 100% visual testing, then it could be also 100% of magnetoscopy, and then you could have perhaps 50% of radiography, which means half the welds will be tested, or half the welds will be tested and in their whole, let's say, circumference or length, or it could be 50% of every weld. So if it's a pipe, it would be half pipe tested. That is more or less gauged based on the risk analysis of each component. But also for these tests, when they are completed, it will have to be done by an inspector, which is also very frequently a third-party inspector. But this person needs to be qualified to their own standards, and they should be included in the project as well. And finally, these inspectors will print out a completed test report that will have the details of which weld has been tested, what materials, what was the test that was done, but also if they had any defects or flaws, they need to be pointed out. And then if there's a big problem in each of these welds, they will have to be repaired. But in essence, they specify which welds have been tested and what extent. Next slide, please. Also quite important, the drawings are essentially what the design of the equipment or structure that is going to be done. It is very frequently done in two separate steps. There is a section for the design that has these original or customer drawings are frequently done by the customer or by an engineering design agency. And then there are the component drawings or isometrics, which are, let's say, a zoomed in version of what is in the original drawings. These are the ones that are going to be interpreted by the assemblers or pipe fitters and the tack welders in order to assemble the pieces correctly and in the right direction. But all of these need to be tracked and they need to be linked to each individual weld. Next slide, please. And in the end, what is the main deliverable of these projects is companies need to put it all into a project package. And in this project package, you will have all the welds that were done. It could be 10,000, 100,000, it doesn't matter. It needs to be in the project package or multiple project packages that are summary of all of the different parts. But every weld needs to be in the project package. And the idea is that not only the welds, but all the documents, base materials, inspection reports, filler materials, certificates, they need to be in here. And you'll be able to, if you do that, you'll be able to have the full weld traceability. I have a sample here at this link This presentation will be later on provided to you all. You can use this link to download a sample that I've generated for this purpose. Next slide, please. So just to summarize everything, the problem is that there is a lot of information, which is problematic because mistakes can occur. Some things can go missing, or maybe some text may be incorrectly typed in. And the problem is also that if you have poor management of this information, it can become problematic or catastrophic if you are extremely negligent. The most common scenario is that, for example, if you do a weld and it is found during production that you were not qualified to weld this weld, the customer may request complete destruction of this weld and redoing this weld. So it could be also a big cost, but it also could be liabilities and really catastrophic problems. So that is why the welding quality systems, according to ISO 3834-2, are becoming more and more necessary to this day. And as we move forward, I guess the requirements will even grow, and as such, having good information will be crucial. And I think this is my last slide. Next slide. All right. Oh, I also got up a couple of useful links. Sample weld tracking spreadsheet if you are getting started with your weld traceability. This is a sample that has pretty much all the fields you'll need in. Sample WPS, just for writing WPS, and the sample project data book that I referenced earlier. And I'd like to thank you all for your attention.
Thank you, Thiago, and Peter as well. Well received. As well, thank you all of you for your participation and the good questions highlighted. I will come to the questions which came in on that regards. And the first one is related to heat input and interpass temperature. And how close to the recommendation we need to be, or is it okay to be close at?